This video is a presentation of Chapter 1 in MTB 1370. Chapter 1 deals with fractions and decimals that are used in healthcare settings. So this will be a very fast-paced overview of Chapter 1. Please make sure you read your book very carefully and complete all the assigned homework in addition to watching this video. Now, as we review these concepts that you've learned in previous math classes, some of it might be a little mundane to you, because it is review. That's why we'll quickly through the content. Now, when we have a fraction involves two numbers, one on top, which is called the numerator, and one on bottom, which is called the denominator. So if I have the fraction 6/11, 6 is the numerator, and 11 is the denominator. When we have fractions, we always like to write them in reduced form, reduced to lowest terms, and we do not want to write them as improper fractions, and we'll talk more about that in a second. When we have a proper fraction is a fraction such as 3/5 or 2/7, where the value of the numerator is less than the value of the denominator. So 3 is less than 5, 2 is less than 7, and down here 5 is less than 8. So when the numerator is smaller than the denominator, it's called a proper fraction, and that is the way that we are going to write all of our final answers as proper fractions. Thus, if you have an improper fraction, the numerator is greater than or equal to the denominator. So if I have 6/5, or if I have 12/7, those are examples of improper fractions, and we do not leave our final answers as improper fractions. So those are both examples of improper fractions, as is 8/5, because 8 is greater than or equal to 5. So when we have improper fractions, we're going to write those as mixed numbers. So for example, if I did have 11/3 as a fraction, 11/3, that is an improper fraction because 11 is greater than or equal to 3. So we're going to convert that to a mixed number. And the way we're going to do that is we're going to see how many whole times 3 goes into 11. And it goes in there 3 times, but not 4, because 3 times 4 is 12, but 3 times 3 is 9. So 3 goes into 11 3 times, and 3 times 3 is 9, so we have a remainder of 11 minus 9, which is 2, that we divided by the divisor, the denominator, which is 3. So 11/3 is an improper fraction, and it's equivalent to the mixed number 3 2/3. A mixed number will be made up of a whole number and as a proper fraction. So it's basically saying 3 plus 2/3. It's a whole number plus a proper fraction. So we just write it as 3 2/3 for short. So 1 5/8 is a mixed number. It has a whole number 1 and the proper fraction 5/8. In mixed numbers, we'll have a value greater than 1, as 3 2/3 is greater than 1, and so is 1 5/8. A complex fraction is a fraction which has a fraction in the numerator, the denominator, or both. So this right here is a fraction, and in that fraction, there's a fraction in the numerator, and there's a fraction in the denominator. So this whole fraction is called a complex fraction. And as it says here, the value could be smaller than 1, greater than 1, or equal to 1. So the key thing is complex fraction means you have a numerator and a denominator that has a fraction in it. And as we proceed through the course, you might have other things besides fractions, such as percents or ratios in the numerator or denominator. Just a quick review, if we simplify a complex fraction, what we do is we take the numerator's fraction and we multiply it by the reciprocal of the denominator's fraction. And the reciprocal of 4/5 is 5/4. And then as we multiply fractions, we multiply straight across. That'd be 10 12. And we always can reduce by dividing out a common factor. 10 and 12 both share a common factor of 2. So dividing the numerator and the denominator by a 2 will give us 5/6, which in this case is a proper fraction. So we started with a complex fraction, but we generally do not want to leave our answer as a complex fraction. So we simplified it, and now we have a proper fraction. Now, this is a visual representation of fractions, and it's one way that you could compare fractions is make a little pie or a circle, and for example, 1/2, divide the pie up into 2 pieces and shade one of those pieces. So we have 1 out of 2 pieces shaded or represented. But if you have the fraction 1/4, you have to divide the circle or the pie up into 4 equal pieces and take one of those smaller pieces, and you can see that 1/2 would be greater than 1/4. It's more of the circle or more of the pie. You could do the same if it was divided up into more pieces. Now, you're not always going to want to do that. So one way to compare fractions, one other way to compare fractions, is rewrite your fractions with the same denominator. Because as you can see on the bottom example, if the denominators are the same, it's easier to compare the pieces of the pie or pieces of the circle because the pieces are the same size. So if I have 1/2 and 1/4, you could rewrite both of those with the same denominator and then compare those fractions. And like the bottom example, if the denominators are the same, 2/5 and 3/5, if the denominators are the same, whichever fraction has the smaller numerator is the smaller fraction. So 2 pieces out of 5 is less than 3 pieces out of 5. So 2/5 is less than 3/5. 2/5 is less than 3/5. So once the denominators are the same, we basically just compare the numerators. And to rewrite 1/2 as something over 4, we got to multiply by a form of 1. And we ask ourselves, 2 times what would give us 4? Well, 2 times 2 would. So if we multiply the denominator by 2, we also have to multiply the numerator by 2, which in effect, 2 over 2 is just 1. So we're really multiplying 1/2 times 1, which is why whatever we get will be equal to what we have, because all we did is multiply by 1. If you multiply the numerators and the denominators, you get 2 over 4. And now you can very easily see, without even drawing the circles, if you have 2 pieces out of 4 and compare that to 1 piece out of 4, well, 2/4 is going to be greater than 1/4, which means 1/2 is greater than 1/4. 1/2 is greater than 1/4. Because recall, 1/2 is the same as 2/4. So 2/4 is greater than 1/4. Now when we have fractions, we already mentioned we like to reduce them to lowest terms. And to reduce a fraction to lowest terms, what we do is we look for basically the greatest common factor of the numerator and denominator and divide both the numerator and denominator by that. So it says divide both terms, that means the numerator and the denominator, by the largest, greatest, non-zero whole number that will divide both into the numerator and denominator evenly. And the fraction you will get will have the same value as the fraction you had. So if we look at the fraction 6/10, we look for the factors of 6. The factors of 6 would be 1, 2, 3, and 6. And normally we don't write them out. We will the first one. The factors of 10 would be 1 and 10 and 2 and 5. And we look for the largest non-zero whole number that they share as a factor. You see they both have a factor of 2. And that's why we divided the numerator and denominator by 2. So 6 over 2, 6 divided by 2 is 3, 10 divided by 2 is 5. So 3/5 is equivalent to 6/10. 6/10 is equal to 3/5. Now, one way you could tell that 3/5 is reduced to lowest terms is look for common factors between 3 and 5. If they only have a 1 as a common factor, that means it's in reduced form. So the factors of 3 would be 1 and 3. The factors of 5 would be 1 and 5. They only have a common factor of 1, which means 3/5 is reduced to lowest terms. So if we had another number, another fraction like 15 over 40, we would look for the greatest common factor of 15 and 40. And we know they have a 1 as a common factor, but we want to find something larger if it exists. And I know 5 goes into both. Does 15 go into both? No. So we divide the top by 5, which would give us 3. Divide the bottom by 5, and you get 8. So we divided by 5 over 5, basically. Divided the numerator and denominator by the same non-zero number of 5. So 3/8 is reduced to lowest terms. Now, when we enlarge fractions, we multiply by a form of 1, which we did in the previous example. So if I start off with a fraction 1/12, and I multiply it by 2 over 2, the fraction I get will be equal to the fraction I had. Because 2 over 2 is what we call a form of 1. And as long as you multiply the numerator and denominator by the same quantity, same non-zero quantity, the fraction you get will be equivalent to the fraction you had. And this is called enlarging fractions. And we need to enlarge fractions sometimes when we are adding fractions and need common denominators. So if I have the fraction 4/7, and I times that by a form of 1, 5 over 5, I will get an equivalent fraction to 4/7, which would be 4 times 5 is 20. 7 times 5 is 35. So 4/7 and 20 over 35 are equivalent fractions. It's just we say 20 over 35 is enlarged. But they are equal. They have the same value because all we did is multiply one of the fractions by a form of 1. 5 over 5 is our form of 1. Now, this leads into adding and subtracting fractions, because when we add and subtract fractions, we need a common denominator. So we have to convert to equivalent fractions with the least common denominator by multiplying each one by the necessary form of 1. So once we have that, then we add or subtract the numerators, and we divide it by the common denominator. So a quick example, there are examples in the textbook as well. If I had the fraction 7/10 plus, say, 3/4. Right now you cannot add those fractions because they do not have a common denominator. One has a denominator of 10, one has a denominator of 4, so you cannot combine them yet. What we first have to do is we rewrite each fraction with a least common denominator. We find the smallest number that both 10 and 4 will go into. So 4 does not go into 10, so we can't use 10 as our common denominator. So we're basically looking for the smallest multiple of the numbers that they have in common. So the multiples of 10 would be 10, 20, 30, 40, 50, so on. Multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, 32, 36. So you can make a list if you wanted to and find the smallest multiple that they share is 20. Another way that you learned in algebra class to do that is prime factor each number. So 10 is 2 times 5, which are both prime numbers. That's called the prime factorization. And 4 is not prime, so we have to factor it into primes. That's 2 times 2. And to find the least common denominator, for those two denominators, what we do is we multiply all the different factors together, using each factor the greatest number of times it occurs in any one denominator. So if you look at these factorizations, the different factors are 2s and 5s. So I'm going to go 2 times 5. And we have to include each factor the greatest or the highest number of times that's included as a factor in either one of our denominators. Well, 2 only occurs once here, but 2 occurs twice over there. So we need 2 factors of 2. So that's 2 squared. 5 occurs once here, and 5 does not occur at all there. So the greatest number of times 5 occurs in any one denominator is just 1. So 2 times 2 is 4, times 5 is that same 20 we said we would get. So we're going to have to find equivalent fractions that have a denominator of 20. And what we do is we go back to our original fraction, and we say, well, our denominator was 10. You could ask yourself, 10 times what quantity would be 20? And hopefully you would say 10 times 2. But if you multiply the denominator by 2, you also have to multiply the numerator by 2, because you have to multiply by a form of 1 to get an equivalent fraction. And 7 times 2 is 14. Another way you could do it is you could look at our common denominator, which is 2 squared times 5, and then compare that to the prime factorization of 10, which is just 2 times 5. And it has all the factors except for that extra 2. Because remember, the least common denominator was 2 squared, and 10 only had 2 to the first. So in order to make the first denominator, 2 times 5, into the least common denominator, 2 squared times 5, we would need to multiply by another 2. So that's another way that you could figure out that 2 was the factor that you had to multiply by the numerator and denominator. Now, which form of 1 do we have to multiply by 3/4? Well, in order to go from 4 to 20, you're going to have to multiply by 5, and if you multiply the denominator by 5, you also have to multiply the numerator by 5, and 3 times 5 is 15. Or again, you could look at the prime factorization of 4, which is 2 times 2, and notice if you want to make it into the least common denominator, it has both the 2's, but it doesn't have the 5. So that's why we would need to multiply that by a 5 to get the LCD. Now, once these 2 fractions have the same denominator, you're almost done, because we keep the common denominator as the denominator. But if it's an addition problem, we add the numerators. If it was a subtraction problem, we would subtract the numerators. In this case, we're adding, so we add the numerators, and we get 29 over 20, because 14 plus 15 is 29. We would not leave our fraction that way, though, because you notice 29 is greater than or equal to 20, which means it's an improper fraction. So we convert it to a mixed number, which we'll get more practice in a few moments with. But 29 over 20. 20 goes into 29 one whole time, and then you have a remainder from 29 to 20, which is 9. And you divide that by the denominator or divisor, which is 20. So 1 and 9/20 would be our answer. And you might just want to check real quickly to see if 9/20 is reduced to lowest terms, and 9 over 20 cannot be reduced. So our answer would be 1 and 9/20. This is just another example of adding or subtracting fractions. Here we have 3 fractions, 2/3 plus 3/4 minus 1/2. So we have addition and subtraction combined in one problem. When we add or subtract, they need a common denominator. The smallest value that 3, 4, and 12 all would go evenly into is 12. So we had to rewrite all fractions with a denominator of 12. So to get a 12 in the denominator, we had to multiply the first fraction by 4 over 4. To get a 12 in the denominator, we have to multiply the second fraction by 3 over 3. And to get a 12 in the denominator of the third fraction, we have to multiply by the form of 1, 6 over 6. And that's how they got 8/12 plus 9/12 minus 6/12. And since we're adding and subtracting, we work from left to right. When we're adding these, we get 17/12. Remember, keep the denominator the same. And 17/12 minus that third fraction of 6/12 gives you 11/12. That's a proper fraction, and it is in lowest terms. When we multiply or divide fractions, we don't need common denominators. We multiply straight across when we're multiplying. So it says cancel terms. That means dividing out common factors. So if I had a problem like 6 over 20, and I'm going to times that by 5 over, let's say, 18. Again, when you multiply, you do not need common denominators. There's nothing wrong with multiplying straight across, getting larger numbers, and then dividing those two larger numbers. That'd be perfectly fine. But here it gives you a hint that you might want to cancel terms or divide out common factors between the numerators and denominators. Because this really means 6 times 5 over 20 times 18. So if there's any factors that can divide out between the numerator and denominator, it makes your work a little bit easier. Now quickly notice that 6 and 18 have a common factor of 6. So if we divide by 6, we get 1. Divide by 6, we get 3. So 6 over 18 is equivalent to 1 over 3. We just reduced it. And 5 and 20 both have a 5, a factor of 5 in common. So divide the numerator by 5, you get 1. Divide the denominator by 5, you get 4. Then if you multiply straight across, you get 1 over 12, because 4 times 3 is 12. And that's the same thing you would get if you went 5 times 6 is 30, and 20 times 18 is 360. Except now you have to reduce that fraction with larger numbers in it. They do both have a 30 in common, so if we divided by 30 over 30, we would get the same 1/12. So you could either multiply straight across and then reduce a little bit, or you could reduce first by dividing out common factors, and then after you've reduced it, multiply the numerators together and multiply the denominators together. We've already divided. Earlier on, we said we left the numerator's fraction as it is, changed the division to a multiplication, and we multiplied by the reciprocal of the denominator. Now, whenever you're multiplying or dividing with mixed numbers, let's say I had 3 1/2 times 2 2/7. This is a multiplication, but it works pretty much the same when you're dividing. You don't want to multiply or divide with these mixed numbers. You're going to want to convert them to improper fractions, do your work with improper fractions, and then simplify your answer. So to convert 3 1/2 to a improper fraction, remember that means the same as 3 plus a half. So 3 is 3 over 1. So to add those, we need to get a common denominator, so we multiply by 2 over 2. So we have 6 plus 1 is 7 over the common denominator of 2, 7/2. Now, a long time ago, you guys learned the shortcut. You took the denominator, you times it by 3 to get 6, and then you added the 1 to get to 7. The reason that works is because, for example, 2 2/7 is 2 plus 2/7. 2 is like 2 over 1. Well, to get common denominators, we're going to have to multiply this 2 by that 7, 7 over 7. We want to enlarge, as it was called earlier, enlarge that fraction. So that would be 14 over 7 plus 2 over 7. So when you do the shortcut, when you multiply the 7 times the 2, all you're really doing is finding the numerator of the whole number when you write it with a common denominator. And 14 over 7 plus 2 over 7 is 16 over 7, which if you did the shortcut, you would get that, because 7 times 2 is 14, plus 2 is 16 over 7. Now, when you have it as improper fractions, you follow, again, this was a multiplication problem. Good that I caught that. And since it's a multiplication problem, we do not need common denominators. So we multiply like we did up here. We multiply like we did up there. And if there's any factors that can divide out, we do that. So 7 over 2 is the first fraction. And then we're going to multiply that by 16 over 7, which is the second fraction. I see 7's divide out, which give you 1. And then 16 and 2 have a 2 in common, so divide by 2, you get 8. Divide by 2, you get 1. And if you multiply straight across, you get 8 over 1, which is just 8. That turned out to be a pretty nice problem. Kind of shocking at that. But our answer there is just 8. So if you were dividing, if I had 3 11ths divided by 2 1/3. Since you have a mixed number involved, the first thing you want to do is convert it to an improper fraction. So that's 3/11 divided by 3 times 2 is 6 plus 1 is 7/3. And then as we did earlier, we leave the first fraction as it is, change your division to multiplication, and change 7/3 to its reciprocal, which is 3/7. Multiply now straight across, you get 9 over 77. Look for common factors. I know factors of 9 would be 1, 3, and 9, and I don't think 3 and 9 go evenly into 77, so that would be reduced to lowest terms. And we actually are ahead of ourselves because it says convert results to a mixed number and or reduce to lowest terms. We did examples of this already. So real quickly, if you have 9/5, that's an improper fraction. To reduce it or to switch it to a mixed number, divide 5 into 9, and it goes in there one whole time, but it has a remainder of 4 because 9 minus 5 is 4 that we divide by the divisor or denominator of 5. So 9/5 is 1 and 4/5. And this is 15/18 is not an improper fraction, but it can be reduced because they both have a common factor of 3. So divide the numerator by 3, that's a divide, and divide the denominator by 3, and you get 5 over 6, which is reduced, and it is a proper fraction. We've been through this before, so this will be a quick one for us as well. The key thing here is if you have a division problem of fractions, change your division to multiplication, and change the bottom fraction, the second fraction, which is called the divisor, to its reciprocal, and then we just multiply straight across. 7 on top, and 4 times 2 is 8 on bottom. And the reason that little method works is if you did have 1/4 divided by 2/7, in effect what you're doing is you're figuring out what to multiply by the denominator, the divisor, to make that into a 1, which would be its reciprocal. But if you multiply the denominator by 7/2, you also have to multiply the numerator by 7/2. This whole denominator is just 14 over 14, which is 1, which means it basically goes away. And then your problem is just 1/4 times the reciprocal of the denominator. And that's why that method works. Some of you might have remembered that as keep, change, flip, or keep, flip, change, something like that in earlier classes. So that was a very quick overview of fractions.